According to Moore's law, the speed and capability of classical computers doubles every 2 years because of advances in technology. Right now, we're at the point where it's extremely hard to fit more and more transistors in the same amount of space. This is where quantum computers come in handy because they provide an alternative form of computation that is unrestricted by Moore's law. But first, let's review classical computing. The technology we use every day operates using zeros and ones. These zeros and ones are stored using charges on tiny capacitors. 8 of these bits make up a byte, which make up kilobytes, megabytes, and so on. This is how information is stored and calculations are carried out on classical computers. Now, what makes quantum computers different from classical computers? Quantum computers use qubits or quantum bits instead of bits. Their values are stored as probabilities of 0 and 1. This property is known as superposition. These qubits are measured by lowering their surrounding temperature to below 0.01 Kelvin, which slows them down and gives them a concrete value of 0 or 1. For example, imagine a cipher that tries to crack a 3-digit password. While classical computers would explore the various possibilities for the password individually, quantum computers can make the process much simpler by exploring all the options at the same time. Next, let's explore the idea of entanglement. In the quantum realm, entanglement occurs when two particles physically interact with each other and become somehow correlated. What? Confused? Here's an example. Imagine that I have a pair of gloves and I give one to my friend John and the other to my friend Wick. If John knows that he has the left glove, he can be sure that Wick has the right glove. Similarly, in the quantum world, the state of one particle can tell us a lot about the state of a correlating particle, even if they're far away. While quantum computers are not readily available in the market today, many tech and banking companies have created their own to exploit their uses, such as this one at IBM. And how are quantum computers useful? Qubits have been used to make passwords more secure and less susceptible to hackers by adding a degree of uncertainty to the process. Many other fields such as genetics, linear algebra, and pharmaceuticals are also being further developed using quantum computers. And of course, what I'm most excited about is the prospect of teleportation through quantum entanglement. The possibilities are endless when exploring this promising field, one atom at a time. Thanks for watching.